The Lockheed Martin F-35 Lightning II is one of the world's most advanced fifth-generation fighter jets. Designed by Lockheed Martin, the aircraft aims to create a multirole fighter capable of performing a variety of missions, from air superiority and ground attack to electronic warfare. The first stage in the F-35 production line begins with a highly complex digital design process. Engineers use computer-aided design (CAD) technology and aerodynamic simulations to create an aircraft structure capable of reducing radar reflection. The fuselage is designed with specific angles for stealth capabilities. The F-35 production uses a combination of advanced materials designed to provide maximum strength while maintaining the aircraft's stealth capabilities. One of the main materials used is carbon fiber composite. This material is much lighter than ordinary metal. The forward fuselage is usually assembled separately from the middle and rear sections. The internal structure is reinforced using frames and bulkheads, which support the stresses during extreme maneuvers. Automation technology helps speed production. The next stage is the assembly of the fuselage. This is the core part of the fuselage and serves as the foundation for the entire F-35 system. The fuselage is assembled using large assembly jigs, ensuring each component is precisely aligned. One of the E-35's main advantages lies in its avionics system. This jet is equipped with an AESA radar, electro-optical sensors, an electronic warfare system, and a high-speed combat computer. The avionics installation phase occurs after the aircraft's main structure is assembled. The F-35 cockpit uses a large touchscreen that replaces many traditional analog instruments. All combat data is displayed in real time to help pilots make faster decisions. The F-35 pilot's helmet is also directly connected to the aircraft's sensor system. The F-35 uses the Pratt & Whitney F135 engine, one of the most powerful fighter jet engines in the world. This engine is capable of producing extraordinary thrust, enabling the F-35 to fly supersonic with high performance. Before installation, the engine is tested separately in a dedicated facility. Technicians check pressure, temperature, fuel consumption, and afterburner performance. The engine is installed using high-precision lifting equipment. The engine is gently inserted into the rear of the fuselage through the engine bay. Once the engine is positioned correctly, technicians begin connecting the hydraulic, fuel, cooling, and electronic systems. All connections must be ensured correctly, as even a small error can cause serious flight disruptions. One of the F-35's key features is its stealth technology. The fuselage is designed with special angles to reflect radar waves in other directions, making it difficult for the enemy to detect. The entire F-35's fuselage uses radar-absorbing materials and a stealth coating that significantly reduces radar cross-section. Even parts like the weapon doors, panel joints, and even the shape of the air intakes are specifically designed to maintain stealth capabilities. Unlike previous generations of fighter jets that carried weapons under the wings, the F-35 stores most of its weapons internally. This helps maintain aerodynamic shape while reducing radar reflection. The F-35 is known as the fighter jet with the most advanced sensor fusion capabilities in the world. All data from radar, infrared sensors, cameras, and electronic warfare systems are combined into a single, unified display for the pilot. This technology eliminates the need for pilots to monitor multiple separate screens. The F-35's computer system automatically analyzes threats and displays the most critical information in real time. This jet is equipped with an AESA active electronically scanned array radar capable of detecting air and ground targets from a long distance with high accuracy. The radar also has electronic warfare capabilities to disrupt enemy systems. In addition to the main radar, the F-35 has a distributed aperture system (DAS), 6 infrared cameras mounted throughout the fuselage. This system provides the pilot with a 360-degree view. DAS technology allows the pilot to see threats from missiles, enemy aircraft, and even objects around the aircraft without obstruction. Pilots can even see through the fuselage through the F-35's advanced helmet display. One of the F-35's most notable features is its helmet-mounted display system. This helmet is more than just a piece of head. It serves as the pilot's primary combat information center. All flight data, targets, navigation, and threats are displayed directly on the helmet visor. The pilot no longer needs a traditional head-up display in the cockpit. The F-35's helmet is also connected to the DAS camera system, allowing the pilot to view conditions around the aircraft in real time simply by moving his head. The F-35 is capable of carrying a wide range of modern weaponry for both air and ground missions. This jet can deploy air-to-air missiles, smart bombs, anti-ship missiles, and even high-precision strike weapons. In stealth mode, all weapons are stored internally to maintain stealth. However, when needed, the F-35 can also carry additional weapons under its wings to increase its attack power. A modern targeting system allows the F-35 to strike targets with high accuracy, even at night or in poor weather. This aircraft also has real-time data sharing capabilities with other military units. Target information can be directly shared with warships, air defense systems, or other aircraft within a single digital combat network. The F-35 is not just a fighter jet, but also a sophisticated electronic warfare platform. Its electronic warfare system can detect enemy radar, disrupt electronic signals, and even help evade missile attacks. This capability allows the F-35 to operate even in areas with high air defenses. The F-35's computer system automatically analyzes threats and selects the best defensive action within seconds. This technology helps increase pilots' chances of survival in modern combat. One reason the F-35 is considered revolutionary is its computer capabilities. This jet uses millions of lines of software code to automatically control various systems. The F-35's combat computer is capable of processing data from multiple sensors very quickly. This digital intelligence technology allows pilots to focus on combat strategy without being burdened by excessive technical work.